Hello and welcome everybody. In this tutorial, we'll learn the protocol stack of SS7. I will give you a brief explanation about the SS7 protocol stack. Note that I'll not be covering a detailed description about the user parts due to time constraints. So let's start. Topics which we will cover in this tutorial are the message transfer part 1 or the MTP1, the MTP2, the MTP3, SCCP or the signaling connection control part, the GT functionality of the SCCP, and some introduction about the user parts. So let's start with the layers of SS7. The first layer of SS7 is the MTP1. It is the physical connectivity of the SS7 protocol stack. MTP2 deals with error correction and detection. It also deals with the message alignment. MTP3 deals with the signaling message handling and signaling network management functions. MTP1, MTP2 and MTP3 combinedly form the transport system of the SS7 protocol stack. The SCCP was introduced to provide more flexible routing than MTP3, such as GT-based routing. The ISDN user part or the ISUP is used for signaling and call control. The TUP, telephone user part, is used for signaling of normal telephony. ISUP and TUP form the call control section of the SS7 protocol stack. The TCAP allows the application called subsystems to communicate with each other over the SS7 networks, such as mobile application part or MAP, camel application part or CAP, INAP or the intelligent network application part. MAP, CAP as well as INAP form the database driven application support subsystem of the SS7 protocol stack. So let's get into detail of the message transfer part of the MTP. MTP1 is the physical connectivity. It is pure transmission of bits from one signaling point to another signaling point. The MTP2 is used for signaling link functions such as reliable transfer of signaling messages, alignment of signaling units, dealignation of signaling units, signaling link error monitoring, error correction by retransmission and flow control. MTP3 has two functionalities: signaling message handling and signaling network management functions. The signaling message handling function of MTP3 is divided into three parts: message discrimination, message distribution, and message routing. Message discrimination provides interface to MTP2 concerned with receiving messages. It determines whether the message is destined to other signaling point or not. If the message is intended to the same signaling point, it will transfer the message to the message distribution. If not, it will pass the message to the message routing and in turn to MTP2. Message distribution delivers the message to its appropriate user part in the same signaling point when the message has already reached the destination signaling point. Message routing also has an interface to MTP2, but this time concerning to be sent from user parts. Message handling is based upon two things: service information octet. Service information octet contains a network indicator and a service indicator. The service indicator is used to identify the correct user part to which the message is intended. And the second is based upon the routing label. The routing label consists of originating point code, destination point code, and the signaling link selections. Some important service indicators: for SCCP 0011, for TUP 0100, and for ISUB 0101 in binary. The MTP3 signaling network management functionality. Traffic management functions. It deals to divert the traffic away from the failed links. The link management functions supply information about availability of the links, and the route management functions. Above the three layers of MTP3, the next layer is the SCCP or the signaling connection control part. Let us discuss some shortcomings of the MTP3. MTP3 is based on network indicator and DPC based routing, hence impossible to reach signaling point outside the network. It is connectionless. It's not compatible with OSI. Some additional features of SSCP: more flexible routing based on GT, that is the global title, can be used to run OSI layers, support TCAP and map layers. Let's see what is global title translation. To solve the shortcomings of MTP3, routing based on GT was introduced. First, GT will be passed to SCCP. GT is some form of translatable address such as normal mobile number. SCCP will use the GT translation table to look for corresponding DPC. Well, then the message will be assembled and passed to MTP. Then MTP will use MTP routing table to determine the corresponding outgoing link set. In this way, the GT based routing is done. The addressing parameters used by SCCP is DPC, destination point code, the global title or the GT, SSN or the subsystem number. The subsystem number of the SCCP is equivalent to service indicator of MTP3, such as subsystem number is used to identify the correct user part to which message is intended. Some important SSNs: ISUP 011, MAP 101, HLR 110, and the VLR 111. The topmost layers of the SS7 protocol stack are the user parts. So let's look for some important user parts. The ISDN user part, or the ISUP, is used for circuit related signaling to set up, maintain and tear down calls. The TUP, or the telephone user part, is used for signaling of normal telephony. The TCAP allows application subsystems to communicate with each other over the SS7 network using agreed upon data elements. There are a number of subsystems that run above the TCAP. Some common examples are AIN, INAP, CAP, and MAP. So that finishes the protocol stack of SS7. I hope this has been informative for you, and I'd like to thank you for viewing.